Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And as always, take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Higher Lower by Jonesy, and here are the rules. Hello, ni hao. Normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. The digits at the ends of a line indicate how many digits on that line are less than 5 and greater than 4. Okay. One end of the line counts the small digits, which are 1, 2, 3, 4, while the other end counts the bigger digits, which are 5, 6, 7, 8, 9. Adjacent digits along a line must not have a difference greater than 5. Oh, that's interesting. So on this line, this would count. Let me try to think of an example. So the number of digits that one end of the line counts the small digits, which are 1 through 4. The other end of the line counts the larger digits, which are 5 through 9. So you could have something like 6 and... No. That's not possible. You can't have 6 big digits in the same box. So you could have 5 and 2. That could be possible. So let's try to figure that out. No two adjacent digits online have a difference greater than 5. So you could have 7 here, 4, 9, 8, 6. So this would be valid because along this line, first of all, we have 2 digits, which are small digits, 2 and 4, and 5 digits, which are large digits, which is 5, 6, 8, and 9. So along this line, the end points, the digits on the end, one end of the line counts the small digits, the 2 counts the 2 and the 4, and the 5 counts the 5, 6, 7, 8, and 9 on the line. And adjacent digits along the line must not have a difference greater than 5. Well, the difference between 2 and 7 is exactly 5, so that's fine. Because you can't have a difference greater than 5. 7 and 4 have a difference of 3, 4 and 9 have a difference of 5, 9 and 8 have a difference of 1, 8 and 6 has a difference of 2, and 6 and 5 have a difference of 1. So none of these differences are greater than 5. So that's how these lines work. And those are all the rules. If you like to play along, or I guess have fun is the last rule, and those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so on each line, the ends are always going to add up to the length of the line, right? Because however many digits are small plus however many digits are large are going to be all the digits on the line. So that means to add up to 5, you're guaranteed to have 1 through 4. Because you have at least 1 of one type, and then 4 of the other types. So this is the same here. This is at least 1 through 4 for this 5 line. To add up to... So these are all low digits there, which means the remaining digits in the box are all high. So that should give us some information. This is 1 and 2, adding up to 3. So this must be a high digit there. And this is, again, 1 through 4 here, adding up to 5 digits on the line. So 1 through 4, 1 through 4. These then, that's 2 lows. 1 and 2 eliminate 1 and 2 in the rest of the row. So this cannot be, that's 3 or 4, adding to 1 and 2, which add up to 5. These add up to 7. These add up to 6. 1, 2, 3, 4, 5, 6. This adds up to 6. So for adding up to 6, we have to have 1 through 5. So these are 1 through 5 there. 1, 2, 3, 4, 5, 6. So that adds 1, 2, 3, 4, 5, 6. So these must be 1 through 5 also. And these have to be 1 through 6 to add up to. But you can never have 6 of ones. As I was saying, in this box, we can never have 6 adding up to a single. We can't have 6 of one set. The most each set can be is 5 in the same row or box. So then this cannot be 1 and 6 here, which makes this 2 through 5. So it's either 2, 5 or 3, 4 here. Anyways, this is 1, 2 as a pair. That means, so this is 3 highs here and 2 lows. So this must be 2 and 3 here. So we have 2 and 3 here. Therefore, this cannot be 2 or 3. It's 1, 4 as a pair. Therefore, this cannot be 1 and 4 adding up to 5, because that would eliminate all possibilities for that cell. So this is 2 and 3. That eliminates 2 and 3 in the rest of the box. We also know, and this has to have 4 lows in it, because it cannot have, it can only have 1 high, and the rest have to be, we have 2 guaranteed lows already here. So then these are both low. That eliminates low in the rest of row 2, because we have 4 lows there. And in box 2, because we have 4 lows there. So these are all high. This is high. And because it cannot be 1 or 4, because that's a low, this would have to be 5 here. So we have 5 guaranteed here, which means this can't be 5. That's a low. 5 and 1 add up together. So this is 5 and 1. That's a high, and that's a low. In row 1, we are missing a 4. So 4 has to be in one of these digits here. So we have 1 low, and the rest are high. That gives us 4 lows in box 3, and this can't be 4, so this is 1, which makes this 5 to add up to 6. So these have to be both high here, because we have guaranteed 4 lows already in box 3, 1 being here, the other 2 being there. 1 eliminates 1 there, so that's 4, which makes that 1. 1 sees both of these digits, so this cannot be 1 and 5, adding up to 6. 2 sees the 2 there, so therefore this can't be 2 and 4 there. 2 also sees 2 there, so this can't be 4. 1 sees the 1 there, so this can't be 5. 5 here eliminates 5 there, so this can't be 2 and 5 there. This can't be 1 and 5 there. This can't be 3 or 4 here because of 3 or 4 in the column. So that eliminates 3 and 2 here to add up to 6. So this is 1 or 4 there. So here we have 5. We already have 3 high digits, so the rest must be high because we only have 1 low. This has 1 low. This is 5 as a high. We cannot have all of these be high, because if they were all high, that would be too many high digits in box 6. That would be 7 of them. So this has to be 5 lows here instead of, so therefore as we have 4 lows, that eliminates lows. 3 or 4 is guaranteed to be low, so is 2 or 3. So is 1, 3, or 4. So is 1 or 4 here, or 2, 3, or 4 there. That means we have a guaranteed 4 lows in box 6, so this can't be low because the rest are high, and in column 8, which means the rest of the digits in column 8 are all high. We have 4 lows in row 5, which means the rest of the digits are not low, because that's all the lows possible in row 5. So they're all high, which means we have 4 highs on this line and 2 lows. So this must be 4 and 2. 1 eliminates 1 there, so that's 2 and 1. 4 eliminates 4 here, so this cannot be 2 and 4 here to add up to 6. I have 6. Let's see, what else do we have? We have 4 lows in column 9, which eliminates lows in the rest of the column. So this must be all high. And this cannot be then 3 or 4. It has to be 5 here, which makes that 2. Oh, that's interesting. Huh. 5 eliminates 5 there, so this is 2 and 4 adding up to 6. 2 is obviously a low. We have 1 high and 1 low here, which means in the remaining digits in box 9, that's 5 highs accounted for. So this cannot be high, it's low. Therefore, we have 3 lows already in this line. So we must have 4 lows on the line, which eliminates lows from the rest of the row, so that means these are both high. Okay. We have 1 low, 1 high. Okay, so 1 high is guaranteed. Okay, these are 5 highs in box 3. That means the last digit is a low, and it is a 4. We are guaranteed... where is 2 in box 6? Cannot be here because of 2 in the column. Can't be here because of 2 in the row. So then 2 has to be here. That eliminates 2 there, so that's 3, which makes this 2. That leaves the last low in column 9 as a 4. This has to be 3, that's 1. 1 eliminates 1 here, so that's 3, and then this must be 3 to add up to 6. So we have 3 and 3 there. This is 1 or 3, we're not sure which. So we have to have... we have to have 3 reds and 3 blues on this line. So we have 1 more blue and 2 more reds. But we don't really have enough information there. This blue has to be a 4. That leaves us as 3 there. So these digits cannot be 1, 2, 3, or 4 because of 1, 3, 4 in the column and 2 in the box. So they have to be high digits. That's high digits left. These can't be 1, 2, 3, or 4 because of 2's in the rows. So these are high digits. That leaves this as a low and is 2. We should have like 8 2's now, right? 1, 2, 3, 4. Yes, we have 8 2's. The last 2 then has to be here. And that's the last low digit on that line, so these must both be high. We have 5 highs in column 1. That leaves this as a low and is 1. We have 1 low, 1 high here. 1 low, 1 high there. So 1s, we don't really have enough information. 4s might give us something, yes. Okay, where's the 4 in column 2? It has to be here. That gives us 4 lows in column 2, so this must be high. Actually, we have 4 lows in box 4, so the rest are all high. That's 5 highs in row 4, so this can't be high, it's low. And that must be a 3. 4 is obviously one of these two. 4 is one of these two, so that's not helpful. Um, um, oh yeah, adjacent digits along a line must not have a difference greater than 5. So there's that. So then this digit, right. So high digits here. This digit is not 5 or more. Cannot have a difference greater than 5 with 1. Same with this. So that's 5 or 6 here. 5 or 6 there. That's 5 or 6 there. This cannot be 5 because of 5 in the box, so that leaves that as 6. 1, 5, 2, 3, 4. 1. 2 next to a high digit can only be 5, 6, or 7. Oh, 5 eliminates 5 here, so that's 6. This can't be 5 or 6, so the only digit here that can be there is 7. Because the adjacent digits along the line cannot have a difference greater than 5. This cannot be 6, it's 5 or 7 there. 2 will be next to 5 or 6 here. Cannot be 7 because of 7 in the column. 2 is next to 5, 6, or 7. No 5 here because of 5 in the row. 2, we don't know if that's high or not. 3 can be next to 5 through 8. So this could be 5 or 8 here. 5 or 8 here. Cannot have 5, 6, 7, 8 here. No 5 because of 5 in the box. 3, 5, 6, 7, 8. No 5 here because of 5 in the row. Okay. Hmm. 4 can obviously be next to any high digit. One of these is 1 or 3. This obviously can't be 3. So, if we try to have a low here, this would have to be high. But 1 can only be next to 5 or 6 on adjacent digits on a line because it has to be 5. The difference has to be 5 or less. So if this were 1, this would have to be 5 or 6, but we can't have 5 or 6 here because of 5 or 6 in the column. So this cannot be low, which means this is high, this is low. 1 cannot be here because 1 cannot be next to 5 or 6 here. So this must be 3, which makes this 1. Okay. We don't have any more information. We know where 3 is. We have 8 3s, right? 1, 2, 3, 4, 5, 6, 7, 8. Yep, we know where the last 3 has to be. It has to be there. That means this digit must be a high because we already have all 4 lows in the row. And again, this cannot be 5 because of 5 in the row, so that leaves that as a 6, which makes that 7, which makes that 8, that makes that 9. 8 eliminates 8 here, so that's 5. 5 eliminates 5 there, so it's 6, which eliminates 6 there, so it's 7 or 8. 3 again can be next to 5 through 8, so no 5 here because of 5 in the row, or the box, so 6, 7, 8. No 6 here because of 6 in the column. Okay. Remaining digits of column 2, we have 6, 7, and 9. No 6 here because of 6 in the row. No 6 or 7 here because of 6 or 7 in the box. So that's 9, which makes this 7, which makes that 6. That leaves us as an 8. 8 eliminates 8 there, so it's 7, which makes this 9. 7 eliminates 7 there, so it's 5. So we have 8 and 9 left here, remaining in row 5. We have to have 5 somewhere in box 4. Cannot be here because of 5 in the row. So 5 has to be there. This becomes 5, 6 as a pair. Remaining digits in column 9 are 6, 8, and 9. 6 can't be here because of 6 in the box. Okay. Remaining digits in box 3. We have 6 and 8. This can't be 6 because of 6 in the column. So that's 8 and 6. 8 eliminates 8 there, so it's 7. This can't be 6 or 7, so it's 8, which eliminates 8 there. 6, 9 as a pair. That eliminates 6, 9 in the rest of the column, so this can't be 9. It's 8 there. Remaining digits in this box are 7 and 9. This can't be 9 because of 9 in the column, so it's 7, 9 there, which leaves that as an 8. 8 eliminates 8 there, so it's 9 and 8. That leaves this digit as a 9 in box 4. Yeah, the rest is just normal Sudoku. Remaining digits in row 2 are 8 and 9. In row 3, we have 5 and 7. This can't be 5 because of 5 in the column, so we have 7 there, 5 there. Remaining digits in column 4 are 5 and 6. This can't be 5 because of 5 in the row, so that's 6, which makes that 5. 5 eliminates 5 there, so it's 6 and 5 there. 6 eliminates 6 here, so it's 9 and 6 there. Remaining digits in column 3 are 1 and 7. This can't be 7 because of 7 in the row, so that's 1, which makes that 7. Remaining digits of row 4, or row 6, are 4 and 7. 7 can't be here because of 7 in the column, so it's 4 and 7 there. We have 1 and 9 remaining in row 7. This can't be 1 because of 1 in the column, so we have 9, 1 there. 9 eliminates 9 there, so it's 8 and 9. That leaves this digit as 8 and this digit as 4. And that's the solution. Pretty straightforward, I feel. I was kind of curious how these higher lower lines would work. I think this is the first time I've ever seen this clue before. Feels like it's pretty restrictive, but I guess with longer lines, you could potentially have longer sets, right? It feels very similar to like Whisper 5 lines in a sense. It's like reverse Whisper 5 lines, I guess. I don't know. It's kind of interesting. Yeah, I don't know. Felt pretty straightforward. But I've done similar types of things where I think counting circles are very kind of similar in this sense. Um, and I'm very good at doing counting circles. So this was, I don't know, felt pretty easy to me, but maybe just easy is fine as a designation. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.